Whenever we have two particles collide together, they will exchange some momentums or exchange energies. And it's actually, if you think about energy in terms of a currency, in terms of money, exchanging the energy is just kind of like exchanging the money. Like I give you $10, which means you get $10, I lose $10. Same for collisions. When I collide into another particles, I will lose, say, 10 joules, and that guy will gain 10 joules. So if we try to think about energy in terms of money, then we can probably try to simulate the money, like the economics in the society from the physics collision perspective. So now I want to show you a simulation. Okay. All right. Usually it is hard to predict what's going to happen in the economics nowadays because there's so many factors. Some people are richer, some people are smart, some people they are pretty, some people they have some advantages, some people they're disadvantaged, maybe they're coming from different countries. There are just so many factors which may affect their economic status. But if we want to know a certain economic phenomena, if we want to know what's real cause, like what's real factor of that phenomena, that's really hard, and that's a really hard question to answer because there are just way too many factors, and we cannot create a simple systems to test out our ideas. So that's why some people they will turn to science and hope that physics can help us solve such a problem, because you can find some similar systems in physics that can somewhat mimic the real world problem. So in this lab, you will use the simulators about the gas kinematics collisions. So when you come to this page, click on energy because we want to trace the energy flow. Okay. So here you will see in this simulation, you will see like a fixed, this is an isolated system. So whatever energy put into the system will be conserved. That being said, if we want to use the particle to mimic the money flow between human, the total money inside the system will be fixed. Okay, so here I'm going to pump into some particle inside my system. Okay. All right, so you can imagine there are more and more people in the game, and they started to play each other. So it's a free market. They started to exchange the energy with each other. So let's wait for a while until it reaches a balance. Okay. So now you can see that it starts to come to the balance. You can see some particles, they are very active, like this one. But sometimes it becomes quiet. It's just like kind of wiggling around at the same spot, not really moving much. Now, if we try to trace and all of this happened in the room temperature. Here you can tune the temperature of the system. You can make it hotter. You can make it colder. Okay, so let's make it back to the room temperature. All right. So now it's fixed. The energy inside the system is fixed. So now my question is, all these particles, they're exchanging energies, and you can see particles, they're fair, they all have the same size. There's no special particles, who is more, like who is coming from a wealthy family, carries a lot of energy, and there's no poor particle as well. So now I want to ask you, we want to know what is the energy distribution. Okay, so it's similar to the money distribution of these particles. Okay, what's their energy distribution? If they move faster, means they have more kinetic energy. If they move slower, they have less kinetic energy. What's that distribution is gonna look like? So here, if you click on this plus, you will see a chart of kinetic energy. So this is what it looks like. So how do we understand this chart? In this chart, you can see a lot of particles in the system, they have almost no energy. They're not moving at all. So they are very poor. But there are some particles here. Some particles are very, very little particles. They have a lot of energy. So it's like they have a lot of money. So if we trace all the energy of this, the kinetic energy of the particles in this system, you will get a distribution like this. We call it exponential distribution. And this distribution, it has a name. It's called Boltzmann distribution. Boltzmann distribution is an exponential decay distribution. Exponential decay distribution. This distribution happens whenever you have a lot, like somehow your system, like it seems like it's a fair system, but somehow most of your systems, most particles in your systems, they don't get any energy, and only a little bit get most of the energy. So there's a like energy inequality here. This is just a fact, like the nature, like what the nature looks like whenever we have a lot of particles in an isolated system. All right, so that's just a fact about the gas kinematics. And if you study more about the physics, you can go ahead and explore, you know, why, like, where's this distribution coming from, and why, you know, why when you trap all the particles in the same box, and this is your outcome. And later on, you will practice, you will go ahead and play with the simulators. Again, you can increase the heat and see how the distribution will change. You can make it colder and see how the distributions will be different. You can also open the lid to make it an open system. You can tune the particle size. You can put in the light particles. Now I put in 400 like heavy particles, but you can put in, say, maybe another 400 light particles and see how that plays out. Like, how does that affect our kinetic energy chart